Hello, everyone. Welcome to the latest episode of Math Talk. We're on the move. We're outdoors. We've got some fancy new lav mics, so it's it's like the beginning of season 2 or something. And I'm joined today by Professor Adam Clay, who's professor at the University of Manitoba, where I did my master's. Do you want to just tell the audience a little bit about your research area and interests?
Yeah, sure. So my work is in orderable groups, which means that it's in group theory, but it also intersects with topology, because my interest in those structures is basically what happens if you take a group that comes from topology in some way. And so when I say comes from topology in some way, I mean maybe it's the fundamental group of a manifold, maybe it's a mapping class group, something like this. And then what would it mean for that thing to have an order on it, some sort of order structure where the elements can be compared to one another. And in doing that, you sort of find yourself able to leverage all sorts of algebraic tricks and tools to come up with topological consequences and vice versa. And so that's really, in a nutshell, what I find myself doing most days. Although, to be honest, I do like the algebra part more than the topology. So I find myself often trying to take topological arguments or facts that I've learned through topology and reframe them algebraically to see if you can sort of get any more leverage once you've written it all down carefully in an algebraic sense.
Nice. So I always like to, after the introduction, start right at the beginning and ask, how you first got interested in mathematics. Was there a certain age when you sort of realized when you liked math? Was there a certain person or book or something that helped first get you interested? How did it all begin?
Yeah, so I would say I just sort of was plugging along and not thinking about those things until the end of first year university. So I was able to go that far without really making a choice, because in my first year of university I took they called it the integrated science program, where you basically take all the first year sciences at once and you don't really give any thought to specialization. And then at the end of that you have to choose, and it may sound silly, but I chose math based on the fact that at that time there were no labs associated with math. And it wasn't because of the fact that I wanted to have a lighter workload, it was because I liked working alone. And so that was why I made the choice at the time. But then when I started my second year, I took a really, really unusual set theory course that was taught using a book where you don't learn about sets, you learn about the category of sets. And so I was
interesting.
Yeah, and
is this like the elementary category of sets? Is it that
yeah, I can't
ECTS or something it's called?
Well, there's a book that was written by, I think it was Roseberg or Levier, I can't remember which.
Yes, yeah, Levier, I think.
Yeah, and it's called Sets for Mathematics is what it's called. And the book starts as a set theory book should, where you're just talking about sets, inclusion, and things like this, but very, very quickly defines a category and says what we're going to do is study the category of sets. And okay, as a second year student, you're not really ready for that.
Right.
But it sort of gave me an idea of where things were going, and I was very excited by that in order to go and sort of learn this abstraction that at the beginning made very little sense, right? It's like as a second year student, you don't have enough sort of examples in your inventory to understand why anyone would define a category.
Right.
But I saw that there was a reason for it, and that sort of inspired me to go and try and learn more. So while the initial decision was 100% because I didn't want to go and work in a laboratory, I wanted to think about things on my own, then I was very quickly inspired for sort of, I'll say, better reasons to continue with math.
So you didn't have much of an inclination towards it before then?
No, not really. Before then, I just found myself sort of, like, for instance, arriving in university, I had to learn how to study, how to sit down and read books, and how to focus, and how to work on sort of getting information into my head. Because in high school, I really just kind of drifted around and did what I wanted. Didn't think too much about anything other than, you know, you have to get decent grades, otherwise you'll get in trouble, things won't go well, right? So I sort of did that, but I didn't put much thought into it, didn't try really hard or focus on anything. And then when even the integrated science program that I was in, I actually checked the wrong box on the university application form and ended up in that by accident. And then I sort of decided, well, I should stick with it because I really don't know what I want to do, so it sounds good. And it turned out to be really intense, and so I had to learn how to focus and work and actually study quite hard. And so there were a lot of lessons that I was learning at that level that I should have learned earlier, I guess, and which really are a prerequisite for being able to want to focus on something. You know?
Yeah. I mean, I was very much in the same boat, you know, and in fact, I didn't even in high school, I didn't learn the lesson that I need to get at least good enough grades to not get in trouble. I don't know if I've mentioned this on the channel before, but I failed grade 12 pre-cal.
Yeah.
But again, it's not because I couldn't do it. It's simply because I didn't put in the effort.
Exactly.
And I already knew I was interested in math at that point, but I was just like, I didn't learn my lesson until my first real analysis course.
So I remember when I showed up at the university, like math classes, there were a whole bunch of things that I didn't know, which in retrospect I should have known. They surely showed them to me in high school. But like for instance, I remember that when I arrived in university, I didn't know what a logarithm was. And they tried to just sort of
I thought the wind was supposed to keep the wasp away.
They tried to just sort of start using them, and I knew that it was a thing that I should know and that probably I'd heard it before, but I had no idea. And so there was a sort of mad scramble at the beginning to get to where I should have been. And then I had to keep up with this program that I'd signed up for, again, accidentally, you know? And overall it was, I mean, I had a lot of fun pushing myself to do that. But it was that was the year that I learned those lessons. Yeah.
I see. So you started with this categorical view of set theory, and then arguably that's what maybe gave you a taste of algebra, or maybe inspired your predilections towards that area. So then how did that evolve through your undergrad? Like by the end of your undergrad, did you what were you thinking you wanted to do? Like how did you end up at your PhD program and I don't know if you did master's first.
I did master's first. Yeah. So I had summer undergraduate research positions every summer of my undergrad, and so at the end of my third year, before my fourth year, the project was to sort of learn enough topology that I could compute homology and cohomology groups of simple spaces with coefficients in Z. And learning, and I was supposed to write a computer program in Maple that did the matrix calculations, where you're using like Smith normal form and stuff like this. So that was my project. And as a source of examples, I was learning a little bit of knot theory as well, but it was mostly diagrammatic. And it happened that Dale Rolfson, my future PhD advisor, was in Halifax for some sort of category theory conference, I think. I'm not sure.
There does seem to be quite a few, like, the category theories going on over there. Like, I know a number of people who are, some, like, friends of mine that are out east doing category.
Yeah, exactly. It's quite big on the East Coast. So I think that there was a conference held there. This would have been in 2002, I believe. And anyway, because I was learning a little bit of knot theory at the time, and I had actually asked my USRA supervisor a not theoretic question that he didn't know the answer to. He said, well, I happen to know that Dale Rolfson is here attending a conference, so I'll get him to come down and talk to you, and maybe he knows the answer. And so I asked him this question, and of course he knew the answer. He was able to figure it out and explain it to me, but I didn't understand anything he said because...
Sorry, one moment. I'm just gonna... I was just double checking your mic's on, sorry.
Yeah, sure. Yeah, so he explained it to me. I didn't understand anything he said, but I could understand that an answer had been given, but I just didn't, right? And so I decided to spend sort of a fair chunk of the rest of the summer trying to understand what he had said. And by the end of that, knowing that I was probably going to apply to grad school, I mean, applications start sort of more or less, or you have to start thinking about it around the beginning of your fourth year.
Yeah.
And so I had made the decision then I should probably apply to work with him.
Right.
And then I did sort of the standard sort of array of courses in fourth year, like measure theory and so on, and a category theory course of some kind, Galois theory, things like this. But through it all, I kept reading a little bit about knot theory and low-dimensional topology, so that when I had applied for grad school, I thankfully got accepted at UBC. I went and I worked with Dale Rolfson. Yeah.
Yeah, I actually, the last guest I had on, we ended up talking about knot theory a little bit, but from a very different perspective. Do you know about this analogy between the prime numbers and knots?
No.
Okay. Yeah, I mean, it's a very number theory thing, but it turns out, if you actually know, there's a big analogy between some number theory stuff and some knot theory stuff, and number theorists have had success in sort of looking at knot theorist theorems and trying to copy them down in number theory language, and so there's sort of a thread of continuity between this and the previous conversation.
I see, yeah.
Okay, so that brought you to your master's program, and then so there, I guess you dove more deeply into knot theory. Like, what was your topic for your master's thesis?
Yeah, so then actually, funny thing. So, yeah, for my master's thesis, I did classes for the first year when I arrived, and UBC was set up where there was just a standard, just like, you know, you're a new grad student here in the master's program, you take these classes. And I did that, and, you know, thank goodness, because
so there wasn't you didn't choose your own courses.
No, I mean,
every grad student takes this.
I had the freedom to choose, but there was something that was very much like, here's the standard package.
I see.
And so I was sort of recommended to take the standard package by my advisor, and I just said yes because I didn't have any strong opinions, and it was a very good idea because it turns out, so sort of any time that you're learning multiple subjects, I kind of imagine that you're like filling up these bars in a bar graph. Right. And then, you know, when you make a jump to a new school, you know, who knows where they're going to start? Are they going to start leaving a gap or start with an overlap? Right? And so his recommendation was to take a whole bunch of classes that ensured that they would all start with an overlap.
Right.
So for instance, I had already taken lots of abstract algebra, but then I remember he recommended a course that began with the definition of a group, and I thought that was ridiculous. But then they went so quickly through most of Dummett and Foote, like most of the book.
Right.
And it turned out to be a really wise decision, right? So I spent the first year just doing classes and really sort of solidifying my background, and then at the end, I remember this summer, I was given a paper on skein modules and character varieties of three manifolds, whatever these things are. And then Dale said, oh, and by the way, I'm going on sabbatical for the year. And I think he went to New Zealand. Or at least for 6 months or something like that.
Right.
And so, you know, and this was sort of at a time when it wasn't expected that everybody's connected to their email all the time. Right. So when he went, he really went. And that's it.
Right.
And yeah, so I knew I had to write a thesis, so I figured that's what this paper must have been, a hint that, maybe you should do a thesis on that. So that's what I did. When he came back 6 or 7 months, I handed him something and I said, is this a thesis? And he said, yeah, okay. And so, what I did was I basically sort of did some expository introduction and talked about the specific paper that he gave me. And the paper was about computing linearly independent families of things inside of some big module. And so what I did is I just slightly changed their method and computed some very minorly different linearly independent families. And then there you go. Is this a master's thesis? And his initial answer was actually, I don't know. I'll have to send this to somebody who knows this stuff. Because apparently it wasn't his thing really, and he wanted to learn it by sort of going and doing it alongside me.
Oh yeah.
Yeah, but then he showed up, and I sort of considered myself mostly done. So I think he sent it to Steve Boyer. I'm not sure. But anyway, it was approved. And so, yeah, master's thesis done. I was done by, I think, around April or May.
Wow.
Yeah.
Oh, nice.
Yeah. Because then I assume the next question is going to be, well, then what about PhD?
Of course.
Yeah. So
yeah.
It's important that I was done by April or May, because I didn't know I didn't know what I wanted to do at that point. I actually wasn't committed to doing a PhD. I just sort of had fun doing my master's.
Right.
And so I decided to take the summer and just kind of figure out what I wanted to do. So to do that, I got rid of everything I owned except for a bike and a tent, and I biked home from Vancouver to Halifax.
Wow.
And I just kind of lived in a tent for about 2 months. And again, this is before cell phones or anything were normal, so I was just biking by myself. I would put up my tent in a baseball diamond or the ditch or something and just stay there. And
did you have a little propane burner stove, or you would just sort of eating small snacks on the go?
No, I started with that, and I kept that until, so I left in May, right? And I kept that until beginning of June, and then it was just really hot all the time, and I didn't want hot meals anymore, so I started eating peanut butter and jam sandwiches and stuff like this.
Yeah.
And so I stopped somewhere in, I think it was in Ontario, and I mailed the stove and a couple other items to my parents' house. And my warm clothes, I think I threw them all in the trash, to be honest, because I'd been sweating in them for about a month. Yeah, and then I continued on. I actually took, I think it's by Gamlin, Complex Analysis. Mm-hmm. Yeah, I took that book with me, and I was reading it the whole way too, because I did complex analysis as one of my courses at the beginning of my master's year, and I really didn't think I understood anything that had happened in that course. So I figured I would bring something to think about, and yeah, I did think about it for about the first month, but then eventually I just focused on riding my bike because it was fun. And and I told myself that what I was doing was figuring out sort of what I wanted to do, but that didn't really happen while I was riding around.
Right.
So I mean, eventually I just arrived at my parents' house. It took 2 months. So if I left in May, I guess that means I arrived in July.
Honestly, that sounds like the dream.
It was pretty good.
Tenting, riding on a bike across the country, doing some math here and there. I mean, that sounds...
It was pretty good. It was pretty good.
Spend a summer.
Yeah, and then, it was really miserable for portions at the beginning. Crossing the prairies, for instance, was miserable because... that year, for some reason, the weather pattern was a little different, so the prevailing winds were coming from the east, so I had a headwind the whole time across the prairies, and it rained. It rained most of the time. I think the worst I had faced, it rained for 12 or 13 days in a row at one point, and that was pretty bad. But then, when I got to Ontario, I didn't want to go down through the U.S. I wanted to stay in Canada, and that means that you all get funneled onto one road. And when I say you all, I mean all the other people who are biking and doing a similar trip, because it turns out there's quite a few. And I met a whole bunch of people and biked with a group of 8 or 9, just sort of random people who were at different stages of their lives doing this for whatever reason.
Oh, yeah.
And I did that all north of Lake Superior. And that was actually when I changed gears and really started enjoying myself. Because before that, it was a bit of a struggle, and you can't, if it's raining all the time. I didn't get to like take out my book and do what I wanted to do.
Right.
Like the weather improved. I met some really interesting people, and I guess there was another lull in Quebec. I ended up hospitalized with food poisoning in Quebec.
Oh.
But then I shook that off and kept going. So it was good and it was bad. But then I genuinely did arrive at my parents' house. Like, I had the intention of figuring out what I wanted to do, but I genuinely arrived there and no clue what to do. And it was really only to go from that to I literally arrived and just sat on the couch and watched TV for like about a month, right? Because I didn't have anything to do.
Right.
And after doing that for a while, I realized that okay, this has got to stop. And then on top of that, I don't really have any idea what I would want to do if I got a job. And I did really enjoy the math that I was doing. So I contacted Dale and I asked him if I could come back and do a PhD. And I had missed every deadline. But I guess I didn't remember doing it, but I had done some minimal amount of paperwork necessary to still have my foot in the door before I left.
Oh.
I don't remember doing it, but and anyway, so then I got into the PhD program at the start of September that year. I guess that would have been in 2005, with Dale as my advisor again. And so then then I flew back and started that. And it seemed like I can't say that I had some revelation as to why it seemed like the right idea or anything, but I had this big life experience and somehow arrived at the conclusion that I was happy doing that before. It seems like a good idea.
Right.
Yeah.
I think these finding yourself trips, it's funny, we feel like sometimes we need to go on this journey or something to find the answers, but one of two things is true is the answer's probably already there, and you're probably not going to realize it from this big trip. It's something, I don't know if you're interested in Zen Buddhism at all or whatever, right? But the problem is it's okay, if for Zen Buddhism you want to let go of desire, right? But then the problem is, the trap is that then you also don't want to desire to let go of desire. Right? It's more just to letting go. So kind of find it reminds me of that anyways.
Yeah, I mean, I do think that it was, in retrospect, sort of not so much about figuring out what to do with your life as it was about just figuring out what I liked already.
Right.
Yeah, what I sort of should have already known about myself, right?
Right.
Yeah,
right.
And so then at the end, really all there was to do was look at what I had been doing and realize that was pretty good for me.
Right, right.
Yeah. So, yeah.
So your PhD built on your master's work, or did you turn in a different direction at that point?
Yeah, so when I got back and I started that, so there had been a couple recent developments in foliation theory that were sort of a big deal. And the one that I remember was there was this paper that appeared in JAMS that said that there are three manifolds that do not admit Rebless foliations, like co-orientable, taut, other nice properties, but Rebless foliations. And Dale told me this was a sort of very revolutionary paper, and he's right in retrospect, and that I should read it in detail, and I should try and just get my foot in the door with foliation theory and learn about what had just happened there. And anyway, so I tried to do that, and I read books and papers about foliations. I did succeed in reading that paper, actually. It's very well written. But then I tried to read introductory material, and I couldn't even do that. It was, and in retrospect, I know why now. That paper is organized in such a way that the main thrust of the paper quickly turns into an algebraic problem. and then I can read it. Right?
I see. Whereas, of course, the introductory material on foliations is going to be a lot more analytical.
Right, exactly. Right, so you find yourself working with differential forms, or maybe you're making these cut and paste arguments or whatever. And anyway, after about a year and a half, I remember I had a meeting, maybe a year and a half. I had a meeting with Dale where I just told him, I can't do it. I don't think I can do it. It's too hard. Like, I just feel like I'm spinning my wheels. I don't understand what I'm supposed to be learning here. And like, I felt really dejected. And he told me, like, okay, well, spend another term taking classes and we'll figure this out. So I went and I took a couple classes. I can't remember in what, but just sort of things, anything,
right.
Just it wasn't supposed to be about what I was thinking about, just different stuff.
Right.
And then I came back after a term of classes and he said, okay, well, I think at that point it was figured out that I liked algebra,
Right.
And so then he said, okay, well, here's a question about orderable groups. And he said, he's been thinking about them a lot lately, and it seems like there is a connection possibly between ordered groups and low-dimensional topology, because they were connected to braids and all of these things, and they were starting to sort of build up all these ideas. So he said, here's a pure algebraic problem in orderable groups, and see what you can do. And the problem was something about showing that there's no ordering on the free group, where the ordering of the elements is completely determined by a finite set of inequalities. So it's like, if you specify that, these 10 inequalities hold, does that somehow specify how any two elements should be compared in the group? Can that ever happen for the free group? Because it does happen for the braid groups, for instance.
Okay.
And so, anyway, I actually felt like I could do something there, and I did manage to solve that more or less by connecting it to a solved problem in the field in another area. So it was like, the answer to that question is no, because the answer to this question is no. And so it wasn't that I sort of solved it from scratch, but doing that algebraic work also gave me time to sort of learn the topological stuff, like about three manifolds and everything, at my own pace, to the point that by the time my thesis was more or less done, I had figured out a whole bunch of algebraic stuff, but I was also comfortable enough working with three manifolds that I could do some cut and paste arguments and make some sort of conclusions of my own, and I was starting to do that, and that just came more slowly to me. And so I think that it was, in the end, like a really good idea to go back and do those courses and sort of shift my focus.
Right.
Because I did, in that time, realize sort of what my preference was and what my strength was. And you can't, you have to challenge yourself. And so I was able to bring up to sort of the right level the things that I was struggling with during the time that I was sort of exploiting my predisposition to algebra in order to actually make progress.
Right.
Yeah.
So that got you on the track of orderable groups then, with a little bit of a differential geometry side hustle. I suppose. And so then I guess when it comes time to do postdocs, then like where did you go? How did you find the postdocs that you did, and were you mostly looking at doing orderable group stuff, or how did all of that pan out?
Yeah, so I finished my PhD in 2010, and that means I would have been looking for postdocs in 2009, right? And in 2009, the sort of big thing that sort of now is driving a lot of work in orderable groups and low-dimensional topology hadn't happened yet. And so the big thing is called the L-space conjecture, where it says that orderability of the fundamental group of a three-manifold is somehow connected to these modern homology theories of three-manifolds, Heggard-Floer homology specifically, and it's also somehow connected to foliations. Like, they somehow all can encode similar information about a three-manifold. So that conjecture hadn't been made yet.
When was that conjecture made?
I think it was 2000. It's hard to say because I think it appeared in print in 2013 or 2012, but it was sort of in the air by like 2011 or something like that.
I see.
But people were sort of ordering fundamental groups before that, but it wasn't for a specific reason.
Right. So this was right before the dawn of that whole...
Before that became a thing that people were working on. And I was trying to apply for postdocs, making a case that I had this set of skills which didn't really have a home yet. And so I actually was not successful in the sense that I applied for postdocs and I got nothing. Then there was the NSERC postdocs, which I had also applied for. And after getting rejected for all the postdocs I had applied for, and my record wasn't that weak. It was just in the wrong area. Like, I had some publications, but they're not necessarily, like, you're going to get a postdoc if you're doing something that other people are doing.
Right.
And if you've gone off and done this sort of relatively esoteric thing on your own, that's not really how you do it. And that's what I had done. And so,
I see.
so none of the postdocs I applied for, didn't get those. Applied for the NSERC postdoc, and I got waitlisted. And so I was like, okay, well, that's the end of that. And so I started thinking about jobs and trying to figure out what to do.
Right.
And then waitlisted worked out. I actually got an NSERC postdoc after somebody declined, I guess.
Oh, okay.
And so then I had already been in touch with Steve Boyer. I had gone and presented some of my work to him. And now that I had funding, he said, yeah, absolutely come. So then I went to Montreal to work with him. And around that time, I started working with Liam Watson as well, because he was doing Heggard-Floer homology and left orderability. And I mean, it was him and Steve Boyer and Cameron Gordon who eventually made the L-space conjecture, like wrote it down in their paper after they had sort of accumulated sufficient evidence and seen what was going on in the research of others around them. And so we wrote a couple papers that were making early connections between orderability and Heggard-Floer homology. But really, when I say early connections, I mean, he knew some theorems in Heggard-Floer homology, and he said, that means this theorem has to hold for orderability. Do you think that happened? And then, then we plug away doing some calculations, and by ad hoc methods, you confirm, oh yeah, it does work that way. A direct connection, no, there's nothing like that. Right. Yeah, so we managed to sort of pull that off, and I happened to have exactly the set of tools to do that at the time. And that was a time, though, when I realized, like, there was a lesson learned at the end of the PhD when I almost didn't get a postdoc. So during the postdoc, I really focused on, like, getting results that were relevant to what I saw happening in the field at the time, which was now the L-space conjecture, which was orderability of fundamental groups and so on. So I really focused on that, and I worked really hard for 2 or 3 years because of the fact that I realized, it could just be the end of the line at some point. And you would have to stop doing what you like. Yeah. And and thankfully that worked out. I mean, so I did a 3-year postdoc there, and then you do the thing, you apply for jobs absolutely everywhere. And I had interviews here, there, and then eventually chose here.
Yeah, I think it's this lesson of needing to connect your work to what others are doing came up in the last interview as well. We were discussing how actually important this fact is, and sometimes it's easy to get lost in So we had a little battery issue, and we missed part of the conversation, so we're gonna head back for a second. So you were just talking, I think we left out on the sort of postdocs. That was about where we left off. You applied a bunch of places, as one normally does, and you landed on Manitoba.
Yep.
You've been at the University of Manitoba ever since. But then we were talking about, where your research sort of went from there, and you had done...
So I said, my first goal was to publish a paper where I didn't use the word orderable groups.
Right.
Yeah, and I did manage to do that eventually, not right away. Oh yeah, I remember now. And the thing that I was saying was, one of the things that I realized was that the strength of like being a specialist in something, very focused like orderable groups, is that you can find connections to other fields, and then you can sort of leverage the strength that you have in order to actually do meaningful things in other areas. And so, as a good example, most recently. So most recently, I was contacted in, I think it was 2019, by somebody who was working in descriptive set theory who wanted me to come and give a talk in the logic seminar. And
so coming full circle back to that categorical set theory.
Exactly. And I mean, I didn't see why I was being invited to that at the time, but I sort of had faith that, like, okay, there's a reason for this. Right. And I knew what it was expected I would talk about, so I went and I gave a talk. And then afterwards, it was explained to me, like, I think there might be a connection between orderable groups and this descriptive set theory stuff. What do you think? And because I've already found some little sort of beginning results. And then, it turns out that's true, and now I find myself publishing papers like on descriptive set theory and the relationship with left orderable groups. And I'm not an expert in descriptive set theory. I would have nothing to say about that subject, sort of if it was standalone and I'm trying to publish papers there.
Right.
But it's the fact that there's this connection between something that I know very well and this other field that allows me to actually have a foothold in the other field where I can learn new things and I can make meaningful contributions. And that's kind of what it took me a while to realize was sort of at least my approach, and I think a very good approach to publishing papers. Like my initial goal of publish something that doesn't use the word orderable groups, because I wanted to sort of branch out. Okay, that was great.
Right.
But that was a really hard way of doing things. Like, you look for connections between what you already know and other areas, and you sort of grow naturally that way, rather than making this abrupt transition.
Right.
And I think that's a lot more enjoyable and actually a lot more effective as well.
Right.
Yeah,
it makes sense. Slowly make that transition. Yeah,
but it's funny that I had to really take some time to figure that out, because like you're right, like saying it out loud right now, it completely makes sense, and it's kind of like, well, of course that's how you do it.
Right.
But it doesn't feel that way when you're really in it. Right.
Well, I was reading, I have this book that's an autobiography by Paul Halmosh, and he was recommending in that at some point in your career you do make a fairly big change.
Yeah.
And I mean, it did seem like eventually what he was talking about was kind of connected, but I guess the way he presented it did make it seem like, the change has to be a bit abrupt. But actually, now that I think back about where his papers landed up, they did sort of there was some connection to what he was doing before. So,
I actually think that that's a really good way of doing things, but I think it's very hard to do that in sort of I don't know how to say it, sort of like the modern mathematical economy, where it's like, there's sort of, there's a lot of pressure to be constantly contributing at a steady rate. I mean, even if, like at the University of Manitoba, we're sort of protected in some formal way against the use of metrics like H-index and whatever in evaluating our work, it still would be extremely difficult until you're well established in your career to take the time necessary to actually do something new.
Right.
Because that means you're going to have to put on hold sort of the things that you're good at, or maybe the things that you've built your career on, for at least like 2 years or something until you've got something sensible to say in another area.
Right.
And that's a very, very hard thing to explain to people, or to even justify, because of the fact that you are taking a risk. Like, maybe you won't necessarily be able to contribute as effectively to the new area or something like that.
Right.
And like, I 100% agree that it's excellent for just personal improvement, probably excellent for your sort of mathematical career in the big picture as well. But if not, and it falls flat, and you don't really get a foothold or make the progress you expected, it's a sort of punishing work environment these past decade or two, and to have that happen.
Right.
So yeah, it's really too bad, because I think that sort of thing should be encouraged, but it's not with how things are currently done. At least that's how it feels to me.
Well, I think maybe the middle ground then would be to still, set your sights on something in the distance and find your way to sort of slowly there. And I think also probably the other thing too is another way to making that work in the modern environment is collaborators, which is exactly how it happened with you, right? It's as you mentioned, you're not an expert in descriptive set theory, and yet you're publishing papers there probably because you publish those with people who said, hey, I think there's a connection, and then you were able to bridge your knowledge, right?
Yeah, that's exactly the way that it can be done, is if you work with collaborators who are experts in the area that you would like to learn something about, and if you find common ground, then that's how you do it. But maybe it would be easier for other people, but for myself, the steps have to be really small in order for me to be able to make the transition and learn new things.
Right.
Like, even if there was a connection to something that was kind of distant, and even if somebody sort of had the idea of the connection in their mind already, personally, I can say I would be very challenged to actually do the mathematics to fill in all the way there.
Right.
It's much easier if the steps are small and the incremental progress is rewarded, where you can already see that you have something new after doing something small.
Right.
And for bigger leaps, I think that maybe that will become... I think that might become easier as you have a sort of bigger and bigger picture view of mathematics as you go on in your career. Because it's easier to do if everything falls under the same umbrella, and that sort of gets larger as you go on.
Right.
And so I think it becomes easier to reach farther as you become more experienced. But certainly for myself and where I am right now, I still feel like I need things to be incremental and the steps to be small. So it can be pretty hard to actually get from where you are to a place that's different enough that it feels like you've made that big change, like you were talking about reading in this book.
Right.
Yeah.
So one thing, I see the weather is slowly starting to turn on us a bit. Normally towards the end of the interview, the question I typically ask is more about the Platonist-realist divide. Do you think math is describing some underlying truth of reality, or is it just a language? Which you can answer that if you want, but maybe to put a slightly different spin on it, because so there was the other day I was looking, there was a post on Reddit, and someone was complaining about the use of canonical in algebra, because sometimes people actually mean, oh, there's some hidden functorial relationship, but sometimes people just mean, oh, it's the conventional choice, and it's confusing that the sort of terminology gets abused between these two things. Anyways, so one person somehow ended up on a discussion about proof assistance, right? And one person's, so when a lot of preamble for this question, but sort of coming up mathematically, I had this vision of mathematics, and sort of still do, as everything is the utmost rigor and absolutely pure rigor and logic. And then someone else was sort of saying, I don't believe in like these people who are doing proof assistance, math isn't about the pure logic and technical details, it's more about the general ideas and the soul, and who cares so much about the rigor. And there was part of me that was very conflicted. I felt very against that. But then as I stepped back, I was thinking about, one of the things that bothered me is the person said, oh, the purpose of math isn't to do this. And I sort of stopped and I thought, well, what is the purpose of math? And I don't think there necessarily is a singular answer, in the same way that for art, it's like there's art that's political, there's art that's just random kitsch, there's art that makes you think, there's art that makes you laugh, right? It's like, it would be insane to say that art can only serve as one function. So with all of that preamble, maybe for you personally, what is your idea of mathematics? Like, are you more about these sort of general big ideas? I mean, feel free to answer the Platonist, non-Platonist question as well, but is it more about these big general ideas? Do you really like the tight, rigorous details? What is sort of your maybe philosophical
fair question. So okay, some preamble from myself first. So here's kind of how I sort of see a bit of what you were talking about. Is I think that there's a bit of a divide between how mathematicians think or want to be doing math, or how they think of their subject, and how they actually do it. And so what I mean is, we all think that all of the things that are published are rigorous, detailed proofs, and you want to believe that like a sufficiently, well-programmed computer could go through and check the proofs. And you kind of have this feeling that that's the amount of rigor that math has in it.
I'm definitely at this point, I'm very well absolved of thinking that the publication.
Yeah, but then at the same time, that is, anyone who's gotten into it a little bit, that's 100% not how we actually do it. And so, like some of my own experiences in working with, published material. I remember early on, I had proved some theorem that, I thought was quite good, and was put on the archive, and it required some level of smoothness of affiliation or something like this, and in order to cite a result that was integral to the outcome of the proof. And I remember after it was posted on the archive, somebody contacted me and said, like, well, that result you're citing is a well-known typo. It doesn't have that degree of smoothness. And okay, so then it ended up being true in the end, because there was an effort in the community to correct the well-known typo, in the sense that the result did end up being true as stated in the place that I wanted to cite it. But the proof that was there required C2 or something, right? And then eventually, after a decade or something, it was fixed. But that's not true at all of everything that appears out there. And so one of the things that I do, to my detriment, I believe, is try and build everything up myself to the point that I'm comfortable using it. And that's... so the consequence of that is, there's good and there's bad. One of the good things is, as I sort of come along and translate things into algebra, which is how and so that I understand them, I end up sometimes, finding a foothold that was overlooked or something, and being able to say something new.
Right.
But the downside is, I consistently am about 5 years behind everybody else. And that's just how it is, right? If I want to do things that way. And so I think that early on, I sort of used to get myself really bent out of shape with trying to frame what I was doing sort of in some sort of way that philosophically made sense to me. Sort of exactly the kinds of questions that you were talking about, where I'm doing things this way, where I'm a little bit slower and I'm doing algebra, but the reason I'm doing it is because of this, right? Deep philosophical reasons why it's correct.
Right.
And to be honest, I just moved on at some point, and the reason I started doing things that way and feeling okay about it is because I realized that's what I need to do in order to be happy with my work. So I know that it would be nice if there was a sort of deep reason and a sort of, I had come to some sort of understanding,
Right.
but at some point it was more that like I reached a sort of personal acceptance of this is how I feel that math should be done.
Right.
And so I do it that way. And I
Right.
understand that it fits somewhere in between where mathematicians sort of want their field to be in terms of rigor and how it's actually done.
Right.
Where, you know, I slow down a little bit more than quite a few people and I hammer out details quite a bit more.
Right.
And it's pretty common that, you know, I submit a paper for publication and the response is like, you don't need all this background, like you get rid of that. And fair enough, it's true.
Yeah.
But the big the big revelation was that it's okay for me to do things that way just because I like it.
Right.
Which
Right.
and you know, and along with that came the sort of, it's okay to also stop struggling with those questions, which I did for quite a while, trying to figure out, you know, where my work fit and what I was doing, but it's okay in the end. Yeah, so I hope that's good enough.
Good. No, that's a good takeaway, and it gives me hope too for the, you know, weird little preferences that I have. That maybe it's okay to.
Yeah. You know, actually, I don't know whether. I'll tell you, one of the best things I ever saw from people who work the same way is take advantage of the fact that you're writing in a PDF where you can make links. So what I've seen done for people who work the way that I do, and I haven't yet done it myself, I'm thinking of doing it on future manuscripts, is I think we're done after this. Yeah, so you write the paper that you know will get published.
Yeah.
But then in the proof, you link to an appendix that has all those extra sentences you want to say.
I've actually been thinking about that because there's a paper I'm working on right now actually, and there's so many extra details that I want to put in, and I'm like, no one wants to read this, but I need it to be in there.
Yeah.
Okay, the appendix, like that's how I'm gonna make it.
The appendix in the papers that I've seen where people have done this, they call it notes for the referee.
Okay.
And then you make it clear that the appendix is not expected to be included in the final version, but it's available for people who need to read those details to feel comfortable.
That is fantastic advice to leave off on.
Yeah.
And the thunder is starting to boom. So thank you so much for joining me today here in Winnipeg. I guess I should maybe show the audience we're in a famous place, Odena Circle. Nice little place at the Forks where the rivers meet in Winnipeg.
Yeah.
And with that, we'll sign off.
Thanks.